Alrighty, here we go. We've done the integer stuff. These rules for multiplying and dividing, frankly, are a lot easier, so let's press on. I think it's remembering your fractions and decimals that are going to throw you. So here we go. Make sure your notes say section 1 or chapter 1, section 3b. This is multiplying and dividing, and now we're getting into real numbers. Ready? Yes, of course you are. You're supposed to say, I was born ready. Here we go. All right, so your learning target today is very straightforward, much like the title of the section now. So I can multiply and divide real numbers. I should really say rational, but I'll leave it the way the textbook headed it up, okay? That's what we're doing. So you've already become a master of the positive negative business when we did the integers. So now really, this is where we have to go. Do you honestly remember how to multiply fractions? Do you? Let's see. Let's take a look at a bunch of examples here. 1/2 times 6/7. Okay, now first of all, I had to write it that way because of how it was being typed on the computer, because it's a lot easier to do that than to try and write it this way. But I'm going to rewrite it this way because it's really important that you focus on numerators and denominators, okay? When you multiply fractions, you do not need a common denominator. What we're simply going to do is make one giant Überfraction, and you simply multiply numerators straight across, denominators straight across, and simplify if you need to. So I could say, well, 1 times 6 is 6, 2 times 7 is 14. That's not in simplest form because I say to myself, oh, they both share a common factor of 2. So I need to factor a 2 out of each of these items, the numerator and the denominator, and I get 3/7 in simplest form. Now, do you remember back when you were first learning this and we taught you that, oh, you can simplify if you can find a common factor in the numerator and the denominator, and you do that first, then you don't even have to worry about simplest form. It'll just automatically turn out that way. Here's what I mean. When I look at this again, I say, ho, 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 don't multiply yet, because you see 6 is really 2 times 3. And the minute that I factor it that way, a 2 in the denominator can divide with a 2 in the numerator to be 1s. And then you would end up with 3/7. Okay, so you can kind of simplify beforehand, and then you don't have to worry about doing more simplification at the end. This says 3.5. Now, before I say let's multiply that by 5/7, whoa. The one thing I will say is if you have a mixed number, the very first thing you need to do is change that into an improper fraction. 7/2, not 3.5, call it 7/2 times 5/7. Oh, I just broke my own personal rule about don't use the X like the multiplication symbol anymore. Goodness sakes, we're in algebra now. Okay, make one giant fraction. There's your numerators, here's your denominators, but I see right away 7 divided by 7 is 1, and you end up with 5/2. Here's the deal. You've been trained so well to always turn this back into a mixed number, which is beautiful. But when we get more and more into algebra, I'm actually going to allow you to leave your answers as an improper fraction if the improper fraction has been completely factored in simplest form. So in other words, don't leave it as 35/14, like if I had just multiplied this straight across. No. That has a common factor of 7. Get it this far. If you want to make it the mixed number, go ahead. But I'll accept either answer. Okay, so let's take a look at this one. 1 2/3. Change that to improper. 5/3 times 3/5. 3/5. Ooh, look at this. One giant Überfraction. 5 divided by 5 is 1. 3 divided by 3 is 1. I get nothing but 1/1, which is just 1. Woohoo! Look at how nice that was, for goodness sakes. That is very cool. And in fact, the reason I wanted to show you that is because there are some cool properties when we get into dividing here. Do you remember how to divide fractions? Do ya? Do ya? We got to talk about two terms here. So look at your vocab words for today. Reciprocal and multiplicative inverse. Isn't that a great word? Multiplicative. Nice. All right. Reciprocal. Does that sound familiar? If I go like this to you, does that even make it more familiar? Nod your head yes. Here we go. A reciprocal is the inverse of a number so that when you multiply them together, you get 1. So basically, maybe I should word it this way. I'll put an S there and say reciprocals are two numbers whose product, I can't even spell, product? No, product is 1. So basically, when I multiply them together, I get 1. Isn't that cool? What does it really look like? That's why I made this motion, because basically, write it as a fraction, and then you flip it. You invert the numerator and the denominator. They switch positions. So in other words, if I had something like 3/4, the reciprocal of 3/4 is another fraction that becomes 4/3. Okay? And if you multiplied these two together, 12 over 12, that's 1. Everything factors out. It's beautiful. Okay? That's what reciprocals are. Or a number that's the reciprocal of another number. Make sure the first number is a fraction. Write the reciprocal. You flip that fraction over or invert the numerator and denominator. Now, this word, multiplicative inverse, this is very similar to what you saw the other day with additive inverse, meaning the same as opposite. Multiplicative inverse is really a synonym for the word reciprocal. Okay? It's the same as the reciprocal. It is a number. When you write it as a fraction, invert it. There you go. Now, why do we need to know this? Well, when you do division, I want you to look at this. If I said, what's 10 divided by 5? Okay, 10 divided by 5, I'd say, well, that's 2. Now I come over here and I say, what's 10 times 1/5? Because see, really over here, 5 is 5 over 1. So what if I take the reciprocal of 5 and I multiply and I get the same exact answer? They're both words evaluate or equal to 2. So dividing by 5, I get the same result as multiplying by the reciprocal. Uh-oh. Uh-oh. Do you know what that means? Here it comes. Are you ready? Sorry, this 7th grade year is kind of a big earth-shattering year. And I hate to break this to you, but here's the deal. It's me with my friends, Adam and Jamie, and guess what? I'm not kidding when I tell you that it's true, it's true. Division really doesn't exist. It's just like subtraction. That really didn't exist either. We had to tell you this because you couldn't really handle this whole idea of a reciprocal when you were younger, but now you can. Division doesn't exist. Do you know why? Because division is just multiplication in disguise. So now when we think of division, actually, it's just a multiplication problem. And don't you all agree multiplying is far simpler than dividing? So here's what I'm going to have you do. Every time you see a division problem, I want you to think of, I'm going to change it to multiplying by the reciprocal. The first number stays the same. I keep it, but I change divide to multiply by the reciprocal. And then, honest to goodness, multiplying is so much easier. So we're going to keep the first number the same, but instead of it being a division problem, we're going to change it to multiplying. So make it times, and then flip your fraction to be the reciprocal. It's that easy. Okay? Here we go. Here's a division problem, and you're looking at it going, icky fractions. Oh, shush. Here's the deal. It's multiplying. Keep -1/2 the same, but now instead of divide, I'm going to change it to multiply. And when I make the multiply, if I want to rewrite it as a multiplication problem, then just go vroop and use the reciprocal of -5/6, which is going to be -6/5. Okay, okay. Think of this as just one big giant uber fraction. One big bar, here you go, straight across top and bottom, unless, of course, you see that you can factor something out of there, which I do, because I can factor a 2 out of this -6. I can factor a 2 out of this, and now I get this. -1 times -3 is +3. 1 times 5 is 5. 3/5 is your answer. Or if you don't like dealing with all this negative business in here, just right at the get-go, say, hey, negative times negative, my answer is going to be positive. And then don't worry about your signs anymore. Sweet. All right, let's see. What else? What else have I got here? Yes, next example. Let's do this one. 8/9 divided by -2 2/3. Keep the first fraction. Oh, wait. You know what? I should really write this as one improper fraction first, because I can't flip it till I turn it improper first. So this is really 2 times 3 is 6 plus 2. This is really -8/3 to begin with. Now notice I still left it division, because first I got to make it a single fraction. Now change divide to multiply by the reciprocal. Divide means multiply by the reciprocal. Make it one giant uber fraction. Sweet. Okay, now if you really want to multiply straight across, and you're going to say my answer is negative because I have a positive and a negative, and then I get 24 over 72, and then you're going to have to keep simplifying that, knock yourself out. But I would rather come over here and say 8 times -3 on the top, or just 3. Let's say I already know my answer is negative. 8 times 3 on top, 9 times 8 on the bottom, and simplify this right away. 3 can go into 9 3 times. And look at, numerator is 1, denominator is 3. Your answer is -1/3. Easy. Awesome, awesome. Next one. Okay, first of all, this isn't an improper fraction yet. Let's make it an improper fraction. Any whole number can have a denominator of 1. Now, the other thing I'm going to do, all this negative stuff, blah, negative divided by negative, same sign, you're going to get a positive answer. Now I'm not going to worry about the negative signs anymore. I'm just thinking 3/4 divided by 9/1. Okay? Okay. Change the division to multiply by the reciprocal. Multiply by the reciprocal. That gives me one giant fraction. I can simplify a 3 out of here, and I end up with 1/12. Hold on, come on upstairs here. Oh yeah, it's supposed to be positive. There we go. All right, this one. First, change this guy into an improper fraction. Okay, so that was the first thing. Make sure you have 2 fractions. Next thing, I'm going to come up here and say negative divided by a positive. I know the sign of my answer. They're different. It's negative. So now I can go to town. So now I'm just going to write 5/6, and I'm not going to worry about the sign because I took care of that. Change divide to multiply by the reciprocal. Multiply by the reciprocal. One giant fraction. Woo! Yes, 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 yes. 3 can go into 6 twice. I get 1/2. Boom. Nice. What about 0, though? 0 is an awesome number, but there's something weird, okay? So if I have the number 0, and I say, what's the reciprocal of 0? So, well, let's see. So 0 could be written as 0 over 1. So therefore, the reciprocal would be 1 over 0. Whoa! Hold on. You can't do that. That doesn't exist in our number system. You can't divide by 0. So we have a little bit of a problem. 0 doesn't have a reciprocal. You can't put it in the denominator. So that means if any time you see dividing by 0, boop, 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 impossible. Can't do it. We say that it is undefined. It doesn't exist. There is no way to describe it because it can't happen. No way, never, never, So let's look at these. 0 over 15. Is that okay, or is that just plain old 0, or is it undefined? Well, think of it this way. If it helps you, think of this as being 0. Fraction bar means divided by 15. You can divide by a number that's not 0. So this is okay. That's exactly 0. But this one, you can't divide by 0. It is undefined. What about multiplying? Is that okay? Absolutely. But when you multiply by 0, it is like one big giant terminator. Blows everything up. You're just left with 0. Okay? So you can divide by a number, and 0 can be in the numerator. You can't divide by 0. That's when it's undefined. And anytime you multiply by 0, it annihilates or destroys absolutely everything. Okay? Look at this one. Whoa. 0 divided by 0? My brain hurts. 0 divided by 0 like this. You'd be tempted to say 1 because, when I say 5 over 5, you'd say, well, that's 1. Yes. If I said 29 divided by 29, that's exactly 1. Yes. But 0 divided by 0? Sorry. Boop, 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 boop. That's the problem right there. Undefined. Undefined. All right, look at this thing. Negative 12 and 350 thousandths times 0. Anything times 0 is 0. So watch for those, okay? Awesome. All right, hopefully most of that was review, but then we're adding all the positive, negative twists into it to give you that challenge. Your assignment in the workbook is page 3. All right? Good luck. Be accurate, slow down, don't be a Speedy Sally, and as always, make the force be with you.